There we go. You should be able to hear me now. Okay. So now that you can hear me, let me say that again. What I was saying is, welcome to another episode of the live coding series. We've got some really interesting stuff planned today. What we're going to be doing is using the power of Kubernetes in order to distribute the proof of work algorithm that we worked on a couple of episodes ago on the same series. And so what we're going to do is we're going to essentially make it so that if you don't have, say, a power server with 128 threads, but you have lots of smaller servers with lots of threads on them, then what you can do is you can use Kubernetes to actually take that algorithm, distribute it across those machines. Now, unfortunately, we're having a few technical difficulties getting the whole terminal to share between the two of us, so we can actually work on this. I'm going to be learning some Kubernetes today, but we're on the right track, and we should be there in just a moment. So Omer should be here now, and let's go over to him. Hey, Omer,
One moment.
can you hear me?
Yes, but the audio is messed up on my laptop side. Just give me one.
All right. So what we're going to be doing today is, as I mentioned, we're going to be distributing this proof of work algorithm on a Kubernetes server. I already have actually a Kubernetes cluster with 3 worker nodes on it. Each worker node has 4 CPU cores, and so we have 4 physical threads that we can run, and 16 gigs of RAM on each one. We don't really need that much RAM for this specific use case, but it's still useful. And so what we're going to do now is we're going to go ahead and see if we can actually leverage all those different machines using Kubernetes. And so now that Omer's back, say hi, Omer.
Hi, everyone.
So a question that I have for you, Omer, before we even begin, if you were to describe what Kubernetes is in the simplest way possible, what exactly does it let you achieve, and how are we going to use it today?
The best way to describe it is something to orchestrate multiple containers across multiple systems. Those systems can be different architects, and they can also be run on different operating systems as well.
Mm-hmm.
I believe Windows 10 currently support Windows containers that's built for Windows, not Linux. Because the way that Windows work right now is that they experiment with VM, which have the Linux kernel, and that's what Kubernetes is used, since Docker is built on top. But the changes so Docker can actually use the Windows kernel.
Wow.
Which I run into some issues before, but it worked. Especially fascinating, I know. But the funny thing is, if you do anything with .NET framework, half the time, if you don't watch what you compile for, you might compile the Windows version or the Linux version. And when you go deploy it, it'd be messed up there. But from my knowledge, I think only Microsoft have Windows enabled, and I think some beta alpha. They haven't really officially released it publicly. Like you have to enable certain flags just to even get those systems to be running.
But it's really interesting that Windows supports containers in the first place, though. That I would have never thought that. Natively too. Wow. Okay. That is incredible.
Technically, Mac doesn't support containers directly.
No, it doesn't.
What they do is they create a VM, and then it doesn't work.
Well, I mean, if you were to run a container on a host system, because of the way the container is, it would need to be a container of the host operating system. So even if you want to run a Linux container on Windows, you would still need to run a Linux machine, right?
Not necessarily.
But the Windows subsystem for Linux would fix that.
But that is what I mean is that I don't know if it will use that subsystem. I think it might be using the Linux itself, not Linux. I mean Windows itself.
Oh. Okay. Well.
Let me just set up on my side VS Code and all that, and then we can start going.
Sounds good. All right. So last time I believe we got to to over 100 million hashes per second. And that was good on an IBM Power server with 128 threads. Now, another thing to think about in terms of performance on that specific instance is, does this use case use things like, for example, SMT on Power servers, simultaneous multithreading? There's some use cases that are a lot more efficient when you don't have simultaneous multithreading. but there are some use cases that are lightweight enough that simultaneous multi-threading really helps in terms of parallelizing your code. And so with IBM Power Servers, at least the Power Server that we had last time, we only had the capability to run at SMT4. And so each physical core was giving us 4 threads to run on. So whereas x86, the most you can do is 2 threads per core, Power can get up to 4 threads per core. And with some kinds of chips, even 8 threads per core. But then again, that does come at a cost of some single thread performance. Again, it all depends on your use case. It all depends on what it is that you're actually doing. But unfortunately, we do not have the power to experiment with those power features just yet. Hopefully, in the future, we will have a bare metal server that we can run on in order to do that. Another thing that I want to mention is that if you do want to follow along with this video, you could absolutely just go to IBM Cloud right now and spin up your own Kubernetes cluster. It's as easy as a couple of clicks. You sign up for IBM Cloud, go to the Cloud Catalog, click on the Kubernetes service, and you tell it what exactly you want. In this case, I've got a single zone cluster, so this is in the Dallas 10 data center. And it has, as I mentioned, 3 worker nodes, each of which has 4 cores. And 16 gigs of RAM. So, Omer, what are we looking like on the setup?
Very close. The whole thing is a little bit more different than what we used to, but
So another thing to think about is that with Kubernetes, and this is actually something that Zeus mentioned in the comments, I believe, is that managing a Kubernetes cluster is quite a bit of work, and it's not really as much programming with managing a Kubernetes cluster as it is system administration, I think. And so a lot of our work today is going to be done in the command line, unlike where we usually are, which is VS Code, because VS Code is code.
yeah. Another thing that we do want to mention is that you can get very into coding when you do Kubernetes, especially with the new functionality like operators, where you can create your own custom resource and define how it behaves. So Kubernetes has some basic resource. So we're talking about pods, which is what run the containers. And then you have stuff like deployments, replication sets, stateful sets, and all of those does is how do we control these pods and how many of these do we need to maintain? So stateful set is basically for anything that would kind of require data and that pod is not able to move to a different node. While deployment, it doesn't matter if you go to a different node because there's no data linked to it. So it's a little bit more easier to work with. You could also create your own behavior. So you can make sure a pod only go between certain nodes. And that's all possible. But the one thing that's not really possible by default is to control like the upgrade path or how do we scale this up and down easily. All those stuff are done through like operators, which kind of enhance some of the functionality. So that stuff can also be heavily coded, but it's just understanding what the product is doing and try to code that in a good way. So I guess a good analogy would be people using Bash or whatever docs, I think that's on Windows, to try to automate their creation, setup, or even scale up of something on their system.
Interesting. So you could go all the way from just simply working with a CLI to creating your own custom operators that gets pretty into the coding behind Kubernetes.
Yeah, so most people just tend to do Helm, which is a kind of a package manager to deploy, the Kubernetes resource. That itself is not that difficult, but you can get into something even more challenging once you get into operator, and it also give you the flexibility to do everything that is needed.
So it's good that it does provide an easy to use interface through something like Helm, but at the same time the flexibility that you would need through something like Operator.
Yeah.
Okay. So another thing that I do want to mention while you set up Omer really quickly is that, of course, sorry, go ahead.
I sent you the link. You just need to join.
Perfect.
And then we should be good.
Wonderful. All right. So another thing is that, of course, the power of Kubernetes is, once again, the whole point of it is that it's a container orchestration platform. And you can't have a container orchestration platform without powerful containers. One of the first popular services to really bring containers into the mainstream, I guess, was Docker, right? And it's interesting to see. There are quite a few different services that you can use today for containerization, at least for Linux. But Docker still is the most popular, as far as I know.
So Docker is the most popular, but it's kind of shipping to something else.
Yeah.
The main reason is that Docker requires you to be root,
Okay.
which is not really the greatest
Interesting.
setup. So anytime you talk to like Docker, you either need to be in the right group or you do sudo,
Okay.
which is not the best use case.
Yeah.
So a lot of like the new something that's going to replace it is Cryo or Podman or even Billhop. All those stuff, they use the same backend, but they can either build or they can run it.
Mm-hmm.
So nothing is fully replacing Docker completely
Mm-hmm.
because it's nothing like just an easy drop-in replacement. But you do have tools that can work better. Like Podman, for example, can run containers very efficiently,
Mm-hmm.
but no one use that to run multiple cluster like setup. They only use that for like a personal setup. While the thing that does multiple setup is called Cryo. Look up, okay, that. And it's very challengeable to really work with it because the CLI is not as simple as Docker, but once you get used to it, it's very similar. It give you like a lot of the same flexibility, like the functionality of it,
Mm-hmm.
but at the same time, it can go really detailed on how people want to like code it.
Mm-hmm.
And there's more time really spent on it. Since Docker was never really designed for Kubernetes to begin with, it was just being used since that's the most popular one at that time.
Mm-hmm. Mm-hmm. Makes sense. So now we're starting to see more purpose-built tools in the market. So that's interesting. You're right. I don't see it completely replacing Docker anytime soon, but who knows? Maybe someday in the future. But anyhow, I think you need to let me into the VS Code session, and then we can get started.
Oh, can you try again?
Oh, sure.
I sent you the link on Slack.
Yep, I already joined that, but I'll join it again.
Okay, because I didn't see the pop-up for like allowing you in.
So, Omer,
So
yeah, go ahead.
no, go.
I was just going to ask, so what's the architecture going to be for how we're going to distribute this? You know, traditionally, because this is like a high performance thing, what I would have done a long time ago is I would have used like MPI, right? I would have sent out MPI on a bunch of machines, but that's the old way of doing this sort of stuff. How are we going to distribute this with Kubernetes?
So the very first thing is let's try to make those endpoints that we can use.
Sure.
We're gonna have like a master slave setup. So one on service is gonna be controlling everything else, and then the slaves are going to compute it.
Mhm.
So let's actually get this to work with an endpoint. So we say go compute this. Here's your seed and some other information, and then a way to stop it.
Okay. So basically, what we're going to do is we are going to set up like, say, HTTP endpoints at on this Go code, such that there's an endpoint that tells us to start hashing and an endpoint that it can call when it actually finds a solution. And then we're going to have some sort of master node somewhere that has that endpoint waiting for a solution and actually calls out to these different workers and tells them to start working.
Yeah, so we're gonna just assume there's nothing built for it. One thing that we use a lot in this code is called channels. You can technically do channels over network. It's nothing really stopping you from doing it. But I think that's kind of going overboard right now.
Yeah, definitely overboard.
Let's just do a very simple one. Even the simple HTTP, that's a simple solution. We can go into we can go into using gRPC for better communication, but again, overkill. Let's just do a simple solution, and once we can get this to work on your laptop, we can move it to the cloud.
Totally, that makes sense.
So for everyone, so the current setup right now is that I'm not sure if you guys are familiar with using SSHFS. So currently right now, we're on my system, but coding on Tammy's system.
It's a pretty, I will say, if I want to word it lightly, it's an interesting setup where VS Code is hosted on his machine, and his machine's VS Code is accessing files on my machine through an SSH file system mounted on his computer, and my VS Code is editing code that's sent up to his computer that is then saved back on mine. So it's we got a little bit of a dance going on here, but it works.
We could have done this. We could just spin up a system, install VS Code, and we do remote connection.
We could have, but now we've got this set up. Let's roll with it.
Yeah, let's go with it. Okay. So the very first thing we want to do is make sure this will work. Last time we tested this was a while ago, so we want to make sure number of CPUs plus that.
And let's
Okay.
also make sure we're not asking it for too big of a problem, like too many bits. Let's just do
I
20.
believe 20.
Yeah. We just want to make sure it works.
Okay.
Also, by the way, while you test that, one thing that I do want to say to everybody on the live stream, we are continuing this work from the previous proof of work episode. So in case you haven't taken a look at that, I do recommend you take a look at that. You don't need to take a look at it right now. You can take a look at it after the live stream and rewatch this or whatever you want to do. But one thing that you should keep in mind is essentially what this program is doing is it's taking a string, and we are asking it to generate another string such that when you append that new string to the string that we input, the SHA-256 hash of the new string starts with a certain number of zeros, certain number of bits that are 0. In this case, we're asking it for 20 bits, but it could be as many as we wanted. Because SHA-256 can't be reversed, this is a brute force algorithm, so we're just testing millions and millions of random hashes. And so, as you can see, our code does work. So we were able to process 126,000 hashes in 0.004 seconds, or 1,668,096 in just 0.05 seconds, which will be even faster if we put it on a machine with even more cores rather than just Omer's Mac. And so...
It does it pretty fast, actually. If I just increase it. Again, this is so nothing
30 million
compared
per
to a
second.
Yeah, this is so nothing compared to a GPU or even an Acer chip, but we're going overboard.
Yeah.
So one thing that you can also use to accelerate it, so in Kubernetes, you can pass devices directly to a pod. So in theory, you can pass the Acer chip directly and let it be compute on that, or even the GPU.
Okay,
So you don't really need just CPU alone. You can do everything.
That is really interesting. We'll take a look at that in the future. Maybe we'll have a different live coding episode on A6. But for now, let's go ahead and build those endpoints.
Yeah. So before we continue, can you go to your terminal timer? Just make sure that you're able to run it.
Oh, sure.
Yeah. So the one problem that we have last time, oh, you don't have Go. Just
but
do
that's
brew
fine.
install Go.
Okay, sure. It's on brew, right?
Yeah.
Okay, so while that installs, but I do have Docker, so we're good to go on that end, and I have OC and kubectl installed. So.
Yeah, that's fine. So the main reason we did this setup is just due to I don't have the credentials to log into the Kubernetes cluster while Tammy does, and that setup is going to take some time, so we just did it this way.
Mm-hmm. So one more thing, so again, I'm not the Kubernetes expert here, but if you go into the IBM Cloud dashboard and you click on the Connect via CLI button, it quite literally just gives you the 2 commands that you need to run to connect to your cluster. So that's quite convenient.
But you still need to run number 1, which is connect to your IBM.
Yeah, I already did that.
Yeah, so the funny thing is the best way to actually use Kubernetes is not with Kubernetes vanilla, is to use OpenShift, because you can enhance the login functionality. So you can give it any username, you can connect it to like an LDAP server or something and have it completely working there.
So, oh yeah, it works on my computer too. So 14 million per second,
Okay.
which is not that great, but
the hashes, again, it could just be you found the hash way too fast.
it's probably the fact that I'm running a live stream server, a browser, 2 different monitors, a webcam, and Zoom. So it's.
Oh yeah, that also makes sense why we want to do everything on my laptop, since I'm just doing Zoom.
Yeah, exactly. But anyhow,
Okay.
this is running on an IBM Cloud server, so we're good.
Let's do on your screen, so we can somewhat.
Am I in my screen? Yeah.
Yeah. So I'm also seeing your screen as well.
Good.
So we also showing that. So the very first thing we want to do is let's extract. Like, we don't really care about how fast it does it right now. So let's just comment all that out.
Comment what out? Oh
The
yeah,
timing.
that. Sure.
Yeah. We don't care how long it takes to hash it. We can do this stuff later. It's going to be very difficult to really compute this, but something we have to kind of deal with later on. We don't need this. Okay. So The very first thing is we need to have a function, and we can just call this POC. And the input is gonna be, what would we call this? The string, the prefix?
We're just calling it a prefix.
Okay. I thought there would be like a special word for it.
No.
And then we want to do, can you type in for the debugging? I just gotta set that up so we can pass it in.
Like the number of bits?
Yes. I'm not sure if you want to do number of bits or how
Let's do
difficult.
bits.
Or... Okay. Let me just correct the hashing portion of it.
So what's this function gonna do?
Just so whenever we create a HTTP server and stuff, we call a function, and the main is just to set up the functionality. So without we need a way to set this up.
Sure.
Correctly.
So the endpoint, when we call the endpoint that tells the worker to do work, this is the function that it's going to call internally within the Go code to actually start doing work.
Mm-hmm.
I'm assuming we're going to have a different function to actually handle getting the input from the HTTP endpoint and passing it to this function, but this is the function that's going to be called eventually to actually do the work.
Mm-hmm.
Also, I do see you can go ahead and code that, but I'm going to quickly answer a question I see from Tassin. He asks, why did you choose Golang for today's project? Now, if you know, on this live coding series, the two highlight languages that we've been using would be Golang and Swift. Golang being Omer's favorite, Swift being my favorite. One of the things that Golang does really, really well is concurrency. And so you can like, for example, use Go routines, and you can scale up to like tens of millions of Go routines, which you couldn't ever do with operating system threads because OS threads are really, really heavy, whereas Go routines are very lightweight and they map to a bunch of different OS threads. And because this task is all about multi-threading, we thought, why not use Go? Now, this doesn't make very much use of Go's kind of concurrency, I will say. As a matter of fact, I'm pretty sure you could get exactly the same performance with like pthread in C. I don't think this is leveraging Go's specific advantages, but still, it's really easy to use Go concurrency because of channels and Go routines. So we're using Go.
So we have implemented this in C, and the performance is slightly. Was it similar or slightly slower?
No, it was extremely similar, and because it's not, deterministic, sometimes C was a bit faster, sometimes Go was a bit faster. It was neck and neck, basically.
Yeah, it was just the main reason why it's more difficult to kind of have it something that's very standardized is that we give it random seeds constantly. We doing multi-threading. It's gonna be difficult to really just this thread get this seed, this one get this seed. We could have done it,
but then again,
it kind of slowed down.
C and Golang get blown out of the water by CUDA anyway, so.
And then CUDA is gonna get blown out of the water with async.
But also, to finally answer your question, we chose Golang because it's really easy to implement concurrency. Although, in theory, we could have easily done the same thing with pre-thread or the Grand Central dispatch, but we are using Golang today.
And Golang is also the favorite language for Kubernetes.
Yes, exactly. It's the favorite language for Kubernetes. So it's a happy coincidence that we happened to implement this in Golang last time.
Yeah, actually was. We were planning to do this in Swift as well. I don't know what happened to Swift implementation, but I think you did it. And it was
we
very
ran out
similar.
of time, unfortunately, but yeah, I did end up writing a Swift implementation too, and it was extremely similar performance because again, this specific implementation for concurrency, it doesn't require complex concurrency stuff. It just requires simple, threading, and so it's pretty interesting.
Typical C22. Okay. Let me just make sure I didn't break anything.
Sure.
Okay. It worked.
Do you want to actually try running the code now and then seeing? Wait, why are you?
I did.
One sec. Why are you converting it to a byte array if it's already a byte array?
Yeah, I was looking for this code, but I didn't see it, so I was assuming it worked. Good catch. No, but that doesn't do anything, by the way.
Yeah,
Yeah, the compiler will just remove it.
I know, but just asking.
Okay. So we can do the next portion on your laptop, or you want on my laptop. It doesn't really matter.
I mean,
The,
look. You're on the SSH file system anyway. Let's just do it on my laptop.
yeah, and we can build off that. So the first thing we want to do is create a HTTP server.
Yep.
So we can just find the best example ever, the hello world for HTTP for Golang.
Where is it?
You go to Google.
Sorry, your audio cut out there.
No, you go to Google for that.
Okay. Go.
I forgot the exact. Okay, just type in Golang MUX.
Well, I feel like this is a pretty good example.
Which one?
This is pretty much exactly what we need.
Yeah, that's a very straightforward one.
I like these super straightforward examples. This is exactly what we need. So
I also like the overcomplicated one as well.
no.
Just go to it.
Why? Okay, fine.
Just trust me.
So go HTTP. What was it?
No, I sent you the link. So type in MUX.
Oh, we're using. So you want to use. You don't want to use net HTTP. You want to use Gorilla. Mux.
Why not?
All right,
Why not?
sure, whatever.
It's very straightforward. Like right there.
Sure. Whatever you say.
It does have a little bit better functionality wise, but again, we can use straightforward.
Sure.
Yeah, just one on top and then do go mod tidy, and it'll fix it up. Oh, you already have it apparently. Okay, yeah, so you just need to do space. There we go. Oh, it deleted it. Okay, let's just copy and paste that example.
I mean, you could do that
And
too.
yeah, I'm doing that right now.
Okay, good.
POW, let's just comment that out because we still need it for a bit. Oh, we also need HTTP imported. You know, I feel sorry for the person that tried to do web dev with Golang. It's like it's never been designed for it, and then you just go do it.
Yeah. Zeus is
I feel
asking,
sorry for that
what
also.
message broker are you using? Are all your services stateless?
We're not really using anything right now, and stateless. Yeah, we don't really have any states to really worry about, because we're just going to do brute force in it, and we don't really care the state. We just give it some seed, and hopefully it will return back something.
Yeah, and if it doesn't, then we also do need to have another endpoint for canceling because we don't want it to keep doing work after another node's already found a solution.
Yeah, that's fine. So let's do this. Let's make 2 endpoints. One for start.
One for cancel.
Yeah. You can write that one. I'm gonna create the functions for these.
So while you get started, do you want me to go ahead and build the master node?
What?
The master node?
It's up to you. We can do both at the same time. So let's do this. Let's make a condition. We will pass in a flag, and then if it's master or slave, and depend on that, it will switch between the functionality.
Or we could just have 2 separate files, one for master, one for worker.
Yeah, we didn't set that up.
That's
like
a lot
that.
cleaner.
We didn't set it up like that. But let's do it right now. Let's create another folder.
Wait, all that we should need to do, as far as I can tell, is make a worker folder.
No. Let's do this. Let's actually go more in specific what we need to do.
Wait a sec. Sorry, your voice cut out. What did you say?
Okay, so let's just do what Golang does by default, like the way the package is. So we have to create a folder called CMD. Inside of that, we can have worker and master, and then from there we
Okay, I
can
feel
just
like a
copy paste.
lot easier way to do it right now would just be create two separate folders with their own Go code within it, with two different
Sure.
main.gos.
Yeah.
So we move everything into worker. Good. So now this file doesn't exist anymore, so we're gonna have to close this.
Yep.
And then reopen.
Yeah, if it
from
does
within.
this now, I'd save it.
Well, we're gonna have to remove main.go then.
Okay.
Okay.
So
there we
make
go.
your master that, and then you can work on that.
Yep.
Are you following me or are you following yourself?
I'm following myself.
Okay, good.
Okay. So now I'm gonna go ahead and create a master folder. And
You know you delete all the work, right, that we just did?
wait, really? No, there's no way.
Yes.
I see the work right here.
Where?
I see it. You can see it on my screen. The start function, the handle func.
Yeah, but we did start and cancel,
Yeah, I did
and
cancel.
also the function, and then the function definitions.
But we have that here though.
Where?
Right here.
Can you save this file?
Saved. It's already saved. Like it's in pal worker main.go.
No, I don't see that.
Maybe you have to close your file. Like I can literally go in my terminal right now and do worker
Can you save
main.go.
it?
Oh wait, you're right. Actually, it's not here. I gotta save this while we still have it. Okay, I've copied this into my clipboard, so we have it. Now, let's see what's the best way to go about this. So if I move worker main.go to
No, you can delete worker.main and just copy the new one.
yeah. Oh dear no.
Oh my god.
There we go. Okay. Now, if I close this finally, go back into it, we should have the latest file, and I should also be able to test just to see.
Oh,
if
Tammy,
we can...
quick question for you.
Yeah.
Zeus asks, is the master node not automatically managed by the cloud? I'm guessing you did the IBM Kubernetes service, right? Or
Yeah.
you created your own?
IBM Kubernetes service.
Yeah, so by default, when he does that, the master's all managed by the cloud, so whatever the cloud provider is. So every cloud provider, they give you the option to just spin up the workers and just pay for that. And nothing else.
This is super confusing, actually. Do me a favor. Close your VS Code. I'm going to close my VS Code. Let's reopen VS Code.
Oh my god, Tammy, why do you have to do this?
It's not my fault. It's VS Code's fault.
This is your fault.
Okay.
Open back.
Also, they're asking, why are we using VS Code today if I like Xcode better? We're using VS Code so we can collaborate, because on Xcode you can't do real-time collaboration. And even in VS Code, it's pretty buggy, as you can tell. But
Look, I don't like VS Code. Tammy doesn't like VS Code, but they do make a good
collaboration. Anyway,
collaboration tool.
give me the real-time link.
I'll give you right now. It's funny that we both dislike this.
Yeah, but we're still using it.
Yes. So my like, you use Xcode a lot. I use IntelliJ Suite a lot.
Yeah,
So
IntelliJ is pretty nice, but it's very, very different.
Yes, it is. I do want to give Swift like ID a try and see how I like it.
I'll tell you, you're
And
gonna love Swift.
maybe I will enjoy Swift, because the main reason I don't like Swift at the moment is mainly because Xcode. I'm not a big fan of it.
It's interesting how a single ID can turn you off from an entire programming language.
If you did, yeah, it does. No, one main thing is VS Code will turn me off for Golang as well. Like, it's just really bad integration. Like, it worked for you right now, but when you get into logger code base, it can get very buggy.
Okay, you gotta let me into the live session, but I think we should be good to go now.
I forgot that I had you. I'm so used to just having it. Do you have?
There we go. Nice. Now it works.
Okay.
Okay, so now if I save test2, and then if I look at the file, yeah, good. Okay, now it's actually saving. Okay, now you can actually get started there. I'll get started with the master, and we'll sync up once we're done.
We'll probably be in an hour.
I don't think
Are you
it
gonna
should take
pass me any? Okay, so before we continue, like before you go
the
to what you do,
arguments for start are basically just going to be prefix and difficulty in bits. That's it.
you're not gonna pass me JSON?
Sorry?
Are you gonna pass me as a JSON?
No, just URL parameters.
Okay.
And then cancel's just going to be cancel. Yeah. And it's also going to pass it a completion endpoint. So that's the endpoint that you call when you're done.
So I'm gonna get a prefix, a completion endpoint.
And a difficulty.
Oh, am I gonna get a prefix at least?
Yes.
Oh, prefix, difficulty, and completion. Okay, I gotta see it.
Yep.
Let me just go into this and see how I can extract those, because I'm not really used to that.
I
Whatever.
built something one time that actually took URL parameters. It's extremely easy.
I'm just so used to getting like JSON and stuff like that.
But sending JSON is not as easy as just sending URL parameters, so I'm gonna take master convenience over worker convenience here.
Okay. I just gotta go look it up. One sec.
Okay, so in the meanwhile, let's get started on the master. So basically all the master needs to do is it needs to have its own endpoint that you call when you want some work to be done, which will then go ahead and distribute to the other worker endpoints. And then from there, we want it so that there's another endpoint on the master that the workers can call if they found a solution, which will send a response to the endpoint that was initially called with the solution. It's not necessarily a pretty necessarily a pretty way to do it, but it's gonna work at least.
At least it's gonna work.
So Tammy, I'm gonna copy some code from the worker. Okay, so when we start, did you find the code yet for getting the...
Yeah.
No, it's not
I'm testing
form.
right
It's
now.
not form. It's query parameters, not form.
I'm just.
Oh
I'm
wait, maybe they
playing
just
around.
call it form in Mux.
That might. I'm just looking to it because I'm just trying different ones right now.
Let's see, Mux.
Actually, let me just go into the definition. Form contain parse form data. Nope, that's not it. Come on, is it?
Okay, so this is how you get it.
You found it?
Yep.
Okay, you are the query. Okay. Please do not tell me they just. Do not tell me I have to do the parsing myself.
No, you don't. You don't. It's
Okay,
a map.
okay.
It's a map.
Okay. Oh my god. I was actually a little bit worried for me. I'm
Oh,
like,
were you?
No, because I'm like, this is so stupid. Like, it should
Next
be built
live
in
coding
already.
episode, custom HTTP parser.
One sec, I got to look more into how to start it because it's not working right now.
Oh, it's not?
No, of course it's not working.
Because you're just telling it to handle, you're not actually...
Yeah, I'm not telling to actually run.
Yeah.
Okay, I want to serve idle time. Okay.
I'm gonna go ahead and take some of your code for the worker.
So apparently, there's actually a thing called listen and serve, but apparently the base example doesn't give me it.
Oh, I wonder why.
I don't know. Allow, let's see if it works. Okay. Let me open another terminal. Carry local host. Is this, okay, this is one on my laptop now, yes. Test, equal, test. Wait, what? Oh. Okay. It worked.
Okay, yeah, it works for me too.
Oh, do you test it yourself right now?
Yeah, we both tested the same thing.
Okay.
Okay, so then what we want to do is we want to get the prefix, which will be params prefix 0, and we also want the difficulty, which, how do you convert a string to an integer again? Go.
What?
How do you convert a string to an integer again?
strconv, I think.
Dot parse in.
No, it's dot. Yeah, sure. You need to pass it to the base for that.
Yeah. And of course it returns an error, which we don't need because we're going to assume that the user gave us the right input. Wait, what else does this need? It's giving me...
Actually, no. I don't think you need the base. Oh,
Really?
you did. Yeah.
I think I do. I've used parse.
Just click on, no, do control and then click
Too
on it. And
few
then
arguments. 32-bit integer. There we go.
Oh my god.
Go is very creative. I'll give it that.
I'll give you that too. Too creative.
Now, how does the master node know the IP addresses of all the worker nodes?
We assume it's hard coded for now. Okay.
Okay.
We will get to that afterwards. So no, the master will never know the IP addresses. By the way.
Wait, what?
They only know the DNS vector for it.
So how exactly?
Let me explain it. Let me explain. So the way that you do anything in Kubernetes, you don't ever reference by IP addresses. There will be a DNS record that get created and you reference by that. So what we're going to do is we're going to reference each of the pod directly with DNS query. That we don't need to do. Kubernetes will just deal with it itself and we just send it off.
Okay.
So your endpoint, you can actually send me your IP address and I can go back against it. But you can also send me what your DNS record will be.
So are we doing communication the real way today, or are we just going in the console and finding the IP addresses and hard coding the IP addresses?
At the moment, we assume everything is localhost.
Wait, what?
We just assume everything is localhost right now. And then when we get into Kubernetes...
But the workers aren't localhost.
For our example right now...
Oh, okay, sure.
We can move it afterwards.
Sure.
So what will happen is you'll be passing in environment variables, config map, or something that tell it what to do.
What's your port number? 8080?
Yeah, just do 8081 or something, or whatever.
8081. Well, I'm doing...
No.
Oh, okay,
For
you're 8080.
you-
Sure, got it.
Yeah.
Do I need to say var?
Yeah, no colon.
Oh.
Yes, I know, it's weird.
Stole the words from right out of my mouth. So, for worker in, yeah, you don't use in and go, do you? Range workers. Well, this is going to give us the worker index, which is useless. We want the actual worker. So then we can just do, well, we want to make the HTTP request now, which again requires a bit of Googling. So, make HTTP get request going. Okay, that's not too bad. Oops.
So should I assume that we're only ever gonna get one and one only?
Like we're not gonna get multiple requests for work?
Yeah.
Yeah, assume that.
Okay.
We don't want to synchronize across working.
I just want to make sure.
Yeah. At least not for today's episode.
So I'll make it so that we will always reject if it is this.
Sure.
Okay, once I got a message, I have to look at.
Okay, so I can use values. And then I can set prefix, difficulty, and completion endpoint, which will be localhost 3366 slash completion. Which I might as well just plop on an HTTP on there. Specify the protocol, never hurts. Then I should just be able to get I should be able to do dot encode, but I'm not sure if I can do that, so let's see. Oh, I can, nice. Okay, so params, and then just params. And we don't care about the response, so. What are all these issues? Undeclared name URL. What? Let's just try running it, maybe see if that works. Cannot use difficult. Okay, well, then I don't need to parse it in the first place then, actually.
I'm gonna do a silly thing right now, but whatever.
Sure. Go
So
right ahead.
when you look at it, do not say silly.
Wait a sec. This is confusing. Oh, never mind. It's not confusing. Okay. One of the master endpoints is complete.
Okay. Oh man, doing the Graceful shut up, like cancel, it's gonna be annoying.
Yeah, that's what I was thinking. That's why I went over to the master. But
No, it is possible to do it. Right?
it's just gonna be annoying, that's all.
Yeah, I just gotta, cause I spent up so much threads How can I do this without? Because we never actually close our like channels before, right? We just end the program.
Yeah, that's a bit of an issue actually. Uh,
No, but
if
I have
we
it. I already found it. I found it.
if we close a channel in Go, will the Go routine just end? Like, will the for loop just?
Mm, it's gonna just error out.
Oh, it's gonna error
It's
out. Oh,
it's
come on. Why is Go so
it's
mean?
I don't know, man. So we can do it. I found a way already.
Okay, yeah, I mean, I'm sure it's possible. It's just
No, no. So the thing
frustrating.
is, the only way we could have done this in a nice way is if we have a channel to begin with. Because what you do is in Golang, there's a special type called select, similar to switch, but select work with channels. So whatever channel we turn first, it will get that.
Okay.
So for example, if we have a channel that we have that's meant to be closed and a channel that's meant to get the next work, if we get the close, okay, like just end your process, just go to the next one, and then it just close all the threads, or go between in this case.
Your audio kind of cut out there for me, at least. I know it's fine for the viewers, but it cut out for me a little bit. But I get your point. So we're going to use switch to see, closure channel in a worker channel.
Yeah.
Makes sense. What's the syntax for channel again? I keep forgetting this. I'll just take a look at our code. Okay, so it's just channel.
How do you forget?
I don't know. It's just one of those things. It's so off that I don't remember it.
I don't remember the syntax for select. Wow.
Don't worry. I'm sure it'll be the first result on Google.
Oh, come on, man. It's so straightforward.
We also do have to
What?
close the tell the send a response to, which I kind of forgot about.
Yeah. Don't worry about that.
I know, but like Mux is an interesting library.
What is that? What are you trying to find?
Just how do you send a blank response? Do you just fmt.fprintf and just nothing?
You don't do anything. Oh, you want to send something.
No, wait. So like in Swift, even if the function returns, the
Mhm.
the connection will not close until you send even an empty response. Like you need to explicitly close the request for the response to be sent. Here, when the function returns, is the request just automatically sent?
They should.
Okay, let's assume that's the case.
Let's just assume that's the case.
All
Because
right.
every time I work with it, I just assume it gets sent.
All right, then in that case, I'm fine with it.
So I gotta send you back the solution. Yeah. I don't think we're gonna get into Kubernetes right now for today, but we can continue in this next
You
section.
don't think so? We have an entire hour left.
Yeah, I know, but the Kubernetes component is gonna get very annoying very fast.
Let's at least get as much as we've done.
Yeah.
As much done as
We will get this to compile and run in Kubernetes, most likely, but actually separating the workers and stuff,
Oh yeah, I don't think we can do
that might not be today. So does Golang have this functionality? Not Golang, I mean Swift. Can you explicitly code in a breakpoint?
Like in code?
Yeah.
No, you need to use a debugger.
Apparently in Golang you can. One time dot breakpoint. I ran it by accident, but I don't know why it does that.
The Go compiler team is a very interesting group of people.
I don't know what the use case for that was. Maybe it was old functionality. Again, Golang is still pretty, I guess, kind of new language. While like even to Swift, they came out later officially, but it's more of a mature language since so many people are working on it and more stuff being added constantly.
I mean, it's debatable. I guess Swift is also pretty mature because there's literally Apple working on it.
Yeah, but the same argument can be like Google is mature because not Google. Golang is mature because Google is working on it.
Yeah, makes sense.
I don't know if they're working on it. I think it's just found by Google. I don't think they're really working on it anymore.
Oh, really?
I don't know. I haven't looked up into who is working on Golang.
Okay.
Oh,
so
what they do for
if
a
we
job.
take a look, the Golang GitHub has 44,000 commits.
Ooh,
And if we take a look,
please don't do this.
if
Don't
we
do
take
this
a
to
look
me.
at Swift, we've got 108,000 commits.
Only if you can see C++, Java, or C. You'd be like, never mind. There'll be like millions probably by now.
But yeah,
I didn't know.
44 versus 108. I know that commits don't mean everything. I completely understand that this is not a good metric, like at all. But I'm just
It's
saying.
like that one example. So what happened is I think they found some star or something in the sky, and the people that did the work, the person that was leading it, this female, she was getting all the credit. People were like, "But she didn't do any of the code. This other guy did like millions of lines." But they neglect to mention that he just copy and paste stuff into GitHub, and like, look, it's a million lines of edit. So that whole thing was a little bit funny.
Yeah. But yeah, Zeus, you are right. Golang is not as big as Swift and LLVM, so you're totally right. Commits are not a good comparison. Swift just generally has more commits because you're working with a fundamentally more complex compiler. So. Anyhow. Okay, so.
Wait, how much commit does LLVM have? I'm actually
Oh,
curious.
LLVM has tons of commits.
I'm actually very curious on LLVM.
Oh, wait, what?
Is it just... Oh. No, isn't the one below it?
Let's see. Yeah, it's the other one. 359,000 commits.
Ooh. Okay. They even have Pythons in here apparently.
Where?
1.4% is Python.
Yep.
Objective-C? Wow, okay.
Yeah, Objective-C is compiled by LLVM.
Okay. And then others. Okay, I see. Wow, C++ is like dominating it.
Sorry? Your
Wait,
audio cut out.
Wait, how do you have LLVM within an LLVM?
Like, this is LLVM IR code.
Oh, okay.
I would assume it's IR code. I don't know for sure.
Maybe? Because it's kind of weird.
We can look. Yeah, it's
It's like-
actually IR code. It's all the test cases.
Okay. It's like having a Golang, making the Golang compiler, but the whole project is like get marked as Golang. Technically, it's a Golang project, but it's required. Okay, let's get back to our work.
Yep. Okay, so master should be done as far as I can tell. It's, again, not the prettiest solution, but it works. How can I help you with the worker now?
So the previous solution, but it worked. something else.
The cancel logic is so annoying to work with, isn't it?
Yeah.
Anyhow, I'll get started on the web endpoints as you do that. This is confusing.
What is?
What does your architecture look like here? Like when the start function is called, what is the start function going to call?
Oh, I haven't. That's all messed up.
Yeah, I can tell.
All I really need is I need a closed channel that be created, and then from there we work from it.
Okay, sure.
You can do whatever you want. All I need is a channel to be created, and a channel have to be a global variable so it doesn't get changed
Makes
for
sense.
once. Because we have nothing to really map at the moment. Susan mentioned you can learn Golang in a day. I think you can probably learn that in 30 minutes. It's a very small language.
Interesting.
Oh, do you ever watch those YouTube videos on learn a language in like 10 minutes?
I think I've seen a couple, but I don't exactly know.
What are you doing?
I'm just taking a look at some of the I'm interested to see what kind of assembly code that Go code actually compiles to.
Okay. Which are we gonna do LLVM or what?
No, this is just regular Go.
Okay.
Anyhow, but yeah,
I'm curious to also see this in Swift.
the performance of this.
No. If you go back to your
Oh yeah,
comparison.
Swift is pretty great.
Okay, I'll be back in like 5 minutes.
Sure. Are you gonna? Okay. All right. Okay. But anyhow, we can continue to work.
You can continue working on the cancel logic.
Sure.
You can kind of see how I did it so far, and you can work it based off
All
that.
right. All right. Sure. Okay. So basically, what we have is a select statement. So I'm actually going to search up the syntax for select in Go so that I can know exactly how this is going to work. So Golang select. I thought it was switch. It's actually select, not switch. So select, and then we have cases. Okay, that makes a lot of sense. So then we actually need brackets, of course. So just do this, and then do this, and just indent, close channel, then move something back into the closed channel. I assume so that we can actually close other workers as well, so other Go routines, and we don't just end up closing one, and then we break from the loop. That does make sense. From there, we have a different Go function. Wait, how does that work exactly? This is ending the function. We don't want that to happen, so we gotta we'll remove that. Then we're going, so it's a Go routine. But wait, isn't this blocking then? Ah, okay, that makes sense. Never mind. We're just putting the initial data into blocks. But maybe we still need that to be in a Go routine. I think we actually do need.
I'm back.
Okay, Omer, a question for you. Why is this not in a Go routine?
Wait, what? Isn't this supposed to be in a Go routine?
Is it? Was it before?
It should have been.
It should have been.
Wait,
Yeah,
what?
that's what I'm saying.
What?
How is this no longer in a Go routine?
Wait, what?
Like
Oh, actually, no, wait, one sec. Oh, yeah, I messed up there.
Yeah, I can tell. Don't control Z because there was a bunch of weird indentation stuff that I fixed for you. So
Yeah, so So this is not supposed to have a select.
Wait a minute. Why would it not have select? How will you kill it?
Yeah, so this one is we're looking at it, right? So this one doesn't actually need select. I messed up.
Oh, so is this like a synchronous function?
No, yeah, because what this is doing is just creating all the map
Okay, so the
pretext.
initial blocks.
Yeah.
Okay.
And we always assume, and what this is doing is we're just importing something into it.
Okay.
We're not actually taking it out. Yeah.
That's why the syntax looked so off. I was like, why is this in a select? I was so confused.
Okay, I messed up. We only human.
It's supposed to be.
Did someone mention that?
What?
That why is that
No,
not in
no.
Go?
I was just confused.
Okay, I'm almost done by the way.
Oh, right. That's good.
Okay, so let me explain my close.
I already explained a bit of the select stuff, but you can go ahead and do a little bit.
Do you understand? So if you look at the case and then close channel and then, do you understand why I'm putting one back into it?
So that you actually end up killing other Go routines and not just one.
Yeah.
Okay.
So you only need to import one and then the rest will just take care of everything else.
Yeah, makes sense.
And then, yeah, I think we're done here.
Perfect. Okay, now we need to work on the endpoints. So how exactly do you plan on sending data to these functions through the endpoint?
So one sec, let me just create a close channel. Just a simple closed channel as a variable, no complex struct. Wait, why are there so much errors? So this is why I don't like VS Code for Golang. Like the errors, it doesn't make sense.
Yeah.
Declare but not use. Wait, what?
I say just try running it and don't listen to VS Code.
Oh my god. Why is VS Code gonna be like this? Yep. Go. Okay. So there's actually an issue. So that's good. Okay, let's go to open an editor. Okay, that's fine. That's fine. What? This doesn't make sense.
Where are you?
No, I mean like this whole thing doesn't make sense.
What?
Like I don't know what it's complaining about.
Where?
So weird.
What's like where? Here?
Oh, okay. Mate, I don't know what the complaint is about.
Okay, so look. What it's complaining about. Oh wait, here. Like here?
Apparently it's complaining there. I don't know why it's
What?
complaining on that.
Okay, that's just a VS Code thing. Try running the code and see what.
I tried.
Wait, it's still complaining there?
Yeah.
No way. 93.
Okay, so apparently line 108. Okay, 108. I did something incorrect with the select.
Okay, one
maybe?
sec. I think I figured it out. Yeah, I figured it out.
Oh my god.
This is why you have to indent your code correctly.
Why does it not just tell me that directly? Like, why do I have to like?
Compilers are way too. Anyhow,
Okay, it worked now.
just one more error. 24.
Oh, that's fine.
Did you delete the start function?
Did you delete the start function? Anyways, I'll be back in 1 sec.
All right.
Can you recreate a start function?
Yeah, I'll do that. Okay, so let's go ahead and create the start function now. So start. We have these two comments that I'm going to go ahead and remove. So what I assume we're going to do, well, first of all, cancel's a lot easier, so I'll just do that one first. So basically, you just want to put one in closed chan, and all the go routines will kill themselves at that point because of the way that we have it set up. Let's see what that error is. No closed chan. Well, I know it exists, so let's ask the compiler. Does closed chan exist? Looks like it does exist. Okay, so VS Code is just throwing a fit for no reason. But start. That's the slightly more complex one. So what we would need to do is extract the parameters, which I already have a code for from the master that I'll just go ahead and copy in. So we have the prefix and the difficulty, but we also want the completion endpoint so that we know what to call. From there, I'm going to go ahead and do POW, so I'm actually going to call it. I'm going to pass it the prefix. I'm going to pass the difficulty. This time, we do want to do a parse int. So parse int base 10 is 32-bit.
So, back. I'm gonna leave in like now a couple minutes in a bit, but let's now implement the completion right now. Let's do that afterwards.
Okay, sure. So how's
No,
this?
you can just leave it like that, and let me just.
So how do we know
We're
when
just-
we have a solution? Oh, a solution channel.
Okay, we will manually test it. Okay.
Return solution, and we can just have this
Oh.
return a string, and then. Well, we gotta convert this to a string.
Yeah, so we get that back. The thing, all this stuff is gonna be one separately. So this itself need to call it like the POW. It doesn't return anything in this case.
Yeah.
Okay, so POW also let's get the return string for this then.
Yeah.
Completion endpoint. And then we just do a carry to it. So and we don't return anything. Can you do the request since you already have another one?
What?
Can you do the request?
Sorry.
Can you do the request in the POW function?
Oh, like you want to send the completion. Oh, okay, sure.
Because this will hold the connection, by the way, when you're
Sure,
doing it.
sure, makes sense. Okay.
And to be more specific, this also have to be use Go,
Yeah, makes
so it
sense.
doesn't like hold up
Yeah.
the connection.
Oops. Okay.
How is this incorrect?
What? I think that's just a VS Code thing. No, never mind. Oh, it's just, it needs to handle an error.
Oh yeah. Oh my god. I swear, the difference between the two IDE does make a difference.
Yeah.
Democracy is supposed to be 64. And
does it really not just handle this? Like, do I need to do this?
No, you need to cast it explicitly to it. I'll be back in a couple minutes, okay?
Sure. How exactly do you cast int64 to int?
Oh, you just do int64, that's it.
No, int64 to int.
We don't need to worry about that.
But it's giving the error. Okay. When you come
Okay,
back,
so
we
good.
can fix it. Huh. Maybe an int32. Oh, yeah, well, we can't convert both values. We gotta do int32. What about just int? It works. Okay. So piece A works, piece B works. Now let's see if we can integrate them. So this is going to be running on port, what? Port 8080, that's good. This will be running on port 8081, we have 8080 specified, 8081. Okay, so now, if we go ahead and run the worker, run the master, but also just send a request to the master with a prefix of, say, Tanmay and a difficulty of like 20. In theory, the response to this should be the solution. There's a good chance something will not work here, but in theory, we should get a response to this, and we aren't. So, that's an issue. But let's see if it's actually doing any work. Well, of course, Mac doesn't have htop, so let's do top. Doesn't look like our Go code is even in the top 10. So let's figure out why that is. Time to start doing some debugging.
I'm back.
Okay. So I tried running the worker and the master and actually sending a request, but nothing happened. So.
Nothing happened, okay.
So let's put some prints in now, shall we?
Let's do that. Oh,
What?
we didn't really make the channel?
Oh, well, yeah, that's definitely an issue, but... I wonder why it did nothing, though. Let's just try...
Are we gonna test this on yours?
Yeah.
Okay, yeah.
But you can see it in the screen. Okay, so I've saved the code.
Let me
go
just look at the...
Run worker, run master. Okay, the worker's not printing anything. That is weird. That means the master is probably just not sending the request.
Yeah.
So let's try.
Let's try to debug it together then.
Yep. Let's try and print out the URL that it's sending to. That's what it's... Oh, it doesn't have a question mark.
It doesn't have the right endpoint.
Yeah, exactly.
No,
Slash start.
No.
Sorry, slash start.
Start.
Yeah, sorry. Okay, there we go. Now things should be a lot smoother.
Hopefully.
There we go, nice. That actually worked. Oh my
Oh,
god.
we actually got something back?
Yeah, we actually got the solution back.
Oh, nice. As Zeus mentioned,
How
you
incredible.
need to write good code for these things.
Yeah, exactly.
What are you making the difficulty now?
It's 25.
You sure I want this on my laptop?
Let's try 20.
Yeah, your laptop might not handle.
Is my laptop really not up to the task?
No, I'm sorry. Your
Even
16-inch MacBook, and I'll be my 15.5-inch MacBook. Wait, what? What's going on
Wait,
now?
what? Can
think
it
they
find
hang it.
one? Did it crash?
Yeah.
Oh no, it's finding the
Oh.
solutions, but it's not returning them for some reason.
Really?
See? The
Oh, you
solution
turned
is
down
here.
solution?
Yeah. But we're not getting the response.
So you are not getting the response.
Well,
Let me see
let's
if
see
you
if
get
the
the response.
let's see if the worker is sending it properly.
So completion endpoint. Yeah, no, the worker is not sending it properly.
Why?
The
Why did we
completion
get the
endpoint-
solutions before and now we're not though?
No. What is the endpoint supposed to be? Like what?
That
Let me
already
ask-
comes through. The completion endpoint already has the endpoint name in it.
Okay, and you put a question mark and then solution equal that.
Yeah.
Okay, so this return a response and an error. So let's check if it's, maybe an error happened.
This is confusing.
Okay. Run this new code.
Okay, I'm gonna restart the master and the worker.
Yeah. Oh, and now I see why you want two screens. It's so much easier to use. Are you using item? Or are you just
Item.
using the default? Yeah.
Okay, so the worker, no error. It got the result. The master probably.
Wait. Why are we holding on to this? Like, why is it? Oh, actually, never mind. Let me look at your code.
It worked before.
Wait, why are we waiting for a channel?
Oh, wait, never mind. I got it. I figured it out. I have figured it out. Hold on a minute.
What are you doing for your solution? Like, solution found is completely incorrect.
What do you mean? No, it is completely correct.
Yeah, but when you start, do we want?
If you look at the code for long enough, you'll figure out
I
why
got
it's
it.
built that way.
I know why it's built that way, but like, we're assuming that the connections are always will be up. Okay.
Yeah, we are assuming that, actually.
Is it working out?
Okay, now it should work. Okay, you didn't modify the master, did you?
I did not touch anything.
Good.
I'll blame this on you.
It works now.
Okay, so your computer actually is not bad then.
Yeah, it's not that bad.
It's not that bad. It's just only a little bit bad.
Come on. Okay, now it's actually just for the sake of my satisfaction. I just want to show everybody that this did actually solve the problem.
Yeah, no, we just want some random stuff in the beginning.
No, but yeah, it works. Okay, so now, Omer, the fun part, Kubernetes.
Okay, so we're gonna do a very simple one,
Yeah.
just to avoid us, like create a doc.
Rudimentary.
Yeah. We are not going to separate the two and get it to scale up and down. We're just going to do something simple since we only have 30 minutes right now. So are you connected to the cluster array?
Well, let's connect.
Okay, I'm gonna cancel your thing since that's not any connections.
Wait, what?
Yeah, no, you didn't log in yet.
Did I not? I
No,
did.
so in your screen, I just exit the program so I can actually.
Oh,
Okay.
okay, that's good. And now,
Can you go back into your Screen terminal so we can show everyone?
but I'm here. This
Is that
is
your
my.
Screen terminal?
Yeah, just do Control A and then N and keep doing that until you get to this screen.
Control A and N. Okay, I see now. Yeah, you actually have OC set up. So you can use, if anyone that's following us, you can use either the Kubernetes CLI or the OpenShift CLI. The OpenShift CLI is built on top of the Kubernetes one, so the functionality is the exact same. I just prefer it a bit more since it's just 2 letters versus what, 6.
So that's why you
And
prefer it?
no, I prefer it because of this. So the very first thing we want to do is we want to create a namespace. We want to call it POC, just easy. This is the reason I prefer it. So in Kubernetes, it's not really easy to switch namespace since you have to constantly do -n.
Yeah, that was annoying.
Or you set the context, which is kubectl set context something something equal POC. And OpenShift, it just OC project POW. And
Yeah,
this does
I used to use kubectl, and having to do -n and then the namespace every time was so annoying. So yeah, I get why you like this.
Wait, why? Why? Please don't tell me.
Also,
Wait,
Zeus,
what?
we're using Kubernetes, but we're using the OpenShift CLI for a Kubernetes cluster. We're not using OpenShift.
Yeah, so apparently the CLI just destroyed the whole thing. What is your command to
Come on, Omer.
set the config? What was that command?
What happened to the port cluster?
The cluster, pull cluster, man. Okay, apparently it just okay. I don't like this anymore. Whatever. I'm just gonna keep using OC. I'm just more familiar with it. A lot of this is just mostly memory reflex. So, Tammy, you can use OC or kubectl, doesn't really matter. I've been working with OC in the last like year and a half, so I just remember that much faster. Okay, so the very first thing you want to do is let's check if Docker is running. Okay, it is.
Where?
On your system.
Oh.
Yep. Okay. So Docker is working. We know that for a fact. We want to make a Docker image now. So the very first thing we want to do is very simple. We're going to create one image that have both the master and worker. And this image is going to be just sleep forever. And then we're going to manually go inside of it.
Why not have a different image for the master and a different one for the worker?
Yeah, I'll come back down to the simple solution, okay? The fastest hack to get this all done. Like, we want to batch stuff together as fast as possible. But yeah, you can technically do that. This code, I really don't know how this is working for you right now. Surprisingly, it worked.
Why the master code?
No, this is working. Yeah, the master code. So let's do this. Let's just create one new file, call it Docker image.
Sorry?
Let's create a Docker file now.
All right, here.
We're gonna do one for worker. Actually, can I move this out?
Sorry, what?
Yeah. Okay, no, I got it. From Golang version on top. And let's just get latest.
Are you doing things on my screen right now?
What?
Are you doing? Oh, never mind.
No. So I just need to double check Golang is a valid Docker image. I think it is. Yes, it is. We're not going for the most efficient. We're not going for the best build. We're just going to, can we get this done?
Mm-hmm.
Okay. So we want to copy worker. Are you looking at my, oh, can you go into your terminal? I mean your VS Code?
Sorry?
Go to your VS Code? Yeah. There's a new project, like new file called Docker file.
Mm-hmm.
Yeah. Okay. So I'm not sure if everyone here is familiar with Docker, but I'm just assuming it might be. Okay, so cd into master worker, and then go build. Actually, I don't like that.
Zeus is saying we should be using a Scratch image or an Alpine image.
I know.
And
No,
we understand
technically-
that. We understand that, Zeus. But right now, our goal is not efficiency. It's just, can we get this working?
To be, Alpine is a little bit overkill too, but I guess for what we needed, Alpine is probably the best way. Technically, we only really need Scratch because what we can do is something called multi-stage build. So we can actually do a Scratch image right now. And what we do is we can do from Golang and then as builder. And then we can do from Scratch or whatever, or Alpine.
Okay, you know what? Let's do whatever's fastest right now.
Yeah, I am doing whatever fastest. Can it build? That's the goal right now. Okay. Go Docker build. So I'm doing the build on my laptop right now. Okay, never mind. Let's do it on your terminal.
We might as well. It's in the screen.
Yeah.
Oh, that's
Docker
all.
build. Okay. It look like it's building, and what is not going on? Up close. Up close. Oh my god.
Just run go get whatever.
No. I'm sorry. I'm really I'm not a big fan of this. Let's do this. Go mod tiny. Let's just call this worker. Like I really don't care about this name.
You need to let me in
What?
to the session.
What
I'm
happened?
back. I don't know. It kicked me off for some reason.
Okay, and then we're gonna call this modular the master. Okay. Let's try this one more time.
Sorry?
Okay. It looks like it's working.
Oh, yeah?
Yeah, it worked.
Nice.
So that's why I was so confused why it was working for you. I'm like, this should not be working.
Because I
you did go get.
Yeah, I did go get.
You did the unforgivable. Okay, so before we do anything else, let's actually test if this works. And we want to go into bash.
You want to do a Docker run. Whoops, sorry.
Sorry.
Go ahead.
Okay, so in here we're gonna have slash worker. Inside of that we're gonna have a worker. So let's spin this in the background. Slash master.
I'll get the curl command. Run master in the background, and I'll get the curl command.
Yeah. So let's see if it works. You're not gonna get that.
Am I not? Okay then.
You should just save this into like somewhere else.
Yeah. What? Oh. What? Oh yeah. Why do I keep forgetting the endpoint name? There we go.
Hey, work. Alright, so let's do this as a Kubernetes service now and quickly go from there.
Yep.
So since you're on the IBM, since you already logged
Sir?
in,
Yeah.
since you already have the IBM cloud, any CR, forgot the exact command. So CR is just the Docker registry, the container registry. And from there we can do some interesting stuff. Okay, just a login function. Okay. Can you go back? Actually, I think I should be able to get it from here. Namespace, I think it's called. Okay, you don't have a namespace. So Tammy, I'm gonna create a new namespace in your container registry.
Sure.
Just to isolate some stuff, and we're just gonna name it POC.
Sure.
now.
Could it be that I'm not authorized to view any namespace? Just go ahead and do it. I don't know.
Oh no. Namespace must be 4 to 30 characters long. Nice.
Just say proof of work. Yeah.
You are not authorized for that specific resource.
Can we do it without a namespace?
We have no Docker registry at the moment.
Ooh. Could we run one? Could we run one locally? That's what I did last time.
You gotta spin one up into the in there. Because so right now there's no way to get the images onto the system. That's what I mean.
Okay, so basically here's what I did last time. It's super hacky, and
They don't tell me you spin up a Docker registry. You spin up a Docker registry, didn't you?
okay, we gotta get this done. We've got 15 minutes. Let's see if we can do it. So,
Okay.
Docker local registry. There's this one GitHub repo with the whole thing. Ah, come on. I won't be able to find it now, will I?
There's no way this will work.
No, it
Go
worked.
forward.
It's worked. I've done this. I don't worry. I figured it out. Come on. Who's the guy? He was on GitHub. This probably
Registry
isn't
proxy
it.
cache?
One sec. No, this probably isn't it.
No.
No, this isn't it. There was this one.
Let's do this. Let me just. You want to just use my OpenShift cluster?
Sure.
We might have to do this on my laptop because
That's fine.
yeah. I don't see it. Okay, let me just start up Docker because I need that. Okay.
Oh, I got it. One sec.
got
I
it?
believe I got it. Yeah, I got it. Okay. So,
Oh my god. Okay, whatever. Let's do this.
let's do it. This is gonna be fun, isn't it?
This is so hacky.
This is very hacky. And we're gonna use ngrok to port forward from my Mac so that the cluster can access my local registry. This...
No, you don't use ngrok.
Oh
I
wait,
thought it was
no.
a script that does it.
Yeah, mine is in
It does
DMZ,
everything.
so we can just... No, we're using ngrok.
We don't need to.
Sorry?
You don't need to.
Why?
Kubernetes does port forward by default.
No, what I mean is the registry is running on my machine.
You messed up.
Oh, well. Yeah.
You deploy a too new of a version of Kubernetes.
Oh, really?
Yeah.
Oh, come on. That is annoying.
Go into that. Okay, let me tell you how to fix it. Go into that doc registry.json.
Sorry, what?
No, go into that YAML. I'll tell you how to fix it.
Where's which YAML?
The docker private registry.json.
Okay.
Yeah. So do you see the very top
Yeah.
API version?
Yeah.
Change that to app, and then v1.
Oh, whoops. Sorry. So change API.
No. The extended /v1 beta.
Yeah.
Change that to apps/v1.
I see. We're probably gonna have to change.
No, that's the only thing you need to change.
Really? Wouldn't
Yeah.
it also be referred to in any other JSON?
No.
No, it is.
No, it's fine.
We have to change it everywhere.
Okay, go ahead, do it.
Wait, don't we? Like, wouldn't it error out again?
No, it should be fine.
I'm still gonna do it because I don't want to mess up again.
Come on, even the proxy is that. So the reason why that doesn't work before, and this is what I was worried about.
Turn validation off with validate false.
Okay. You wanna just go on my cluster now?
Yeah, let's do that.
Yeah. Are we on the same screen anymore, or?
No, you just do Control AN and then you can go wherever. There we go.
Are you connected to?
I'm on your same screen now.
Yeah. Are you connected to the firewall, or is this?
What do you mean connected to the firewall? Oh, the
Yeah.
IBM. No.
Yeah. Okay. Okay. Let's do it on mine. Let me just quickly connect so I can get access to my clusters. This is a very hacky way of doing stuff.
It is. It is.
It's very hacky.
But this solution did work for me quite a few times, and it saved my life a few times too.
It's because your version is too new.
Yeah.
Okay, so I go back to VS Code.
Oh, VS Code. Yeah.
Yeah. So go change the terminal to 1.
Sure.
Go to bash.
This one or this one?
Is that the one? Yeah, the one that say go sum, go mod. And
Oh
stuff.
yeah, I'm here.
Okay. So I'm just logging in quickly into my cluster, and then we can do it from there. New project. We're gonna call this what? POC. Okay. Docker build. Let me just quickly build this. There's one thing I do need to quickly get, which I don't know the command off my head.
All right.
Give me one moment. I need to grab something from one of my systems.
Sure. So this is an OpenShift cluster that we're deploying to?
Yeah. It's not my fault.
How many nodes do we have on this cluster?
You can do old secret node.
Well, yeah.
4 workers, 1 master.
Nice.
Someone mentioned Stack Overflow is down. It's a sad day.
That's very sad.
Very sad day. Where is the Registry? Okay, found it. Okay, So I'm just gonna do something quickly. So the registry information for us is gonna be this.
Also, yes, Zeus OpenShift is by Red Hat. As far as I
Yes.
know, it's heavily based off of or has the same core as Kubernetes, right?
Heavily based off it. Kubernetes constantly like get a lot of features from OpenShift because OpenShift upstream everything constantly.
Okay.
There's only certain stuff that they don't publish, but majority is there.
Okay.
Let me just double check this work. Okay. Okay. So the very first thing we want to do is we want to build the image.
Mm-hmm.
So this is the same thing as before, but the one thing I'm going to change is I'm going to give it a name. In this case, I want to do the registry information and then POW calling latest just because, and this. So now I'm able to push if I'm logged in, which I'm pretty sure I'm not. No. So Docker login.
How is
Oh no, I have to do this.
what's
Okay.
wrong?
One sec, I have to add this as insecure. Did someone ask a question?
No.
Are you gonna ask a question?
No.
Okay. So by default, the reason why local Docker registry is a little bit annoying to work with
Yeah.
is because it's hard to push with. I might have podman install. I can do that. Bill ha. Forgot the command. Nope, I'm not able to do that.
If we can't figure it out right now, then next week we're gonna have to continue the same thing. Cause
No.
I
I need to change. I need to restart my Docker.
Oh yeah.
Yeah. So what I need to do is I need to add myself as a authorized Docker registry, since this is an insecure one. Docker is a little bit annoying when it comes to that stuff, but safety, you know. Okay. My Docker is just started now, and after it's done, it will be applied. If that's the case, I can just push.
Have you restarted your Docker yet?
Yep. Let me see if I get the same error. And okay, I got another error, which is fine. So Docker login. I need to log into this registry. -u. Oh, 3.1.9. -p. Okay. And we push in. Yeah.
Finally.
Yep. Are you gonna say something?
Nope. No, I was just gonna.
By the way, I'm like, wait, are you gonna say something now?
No.
Okay. So the one thing I do want to really clarify, the link that we push into is not the link that we're gonna use within Kubernetes, because there's something gonna be called external URL and an internal URL. So Docker Registry, we have an external one, but we don't want to go outside the network and come back in. It's kind of useless.
Yeah.
So we want to just pull directly.
Okay.
Since it have access to pull directly, we might as well use it.
Sure.
Oh, yeah, this is a very big image. Zeus is right. We should have just made it more compact.
Yeah. Well, we're almost done anyway.
Yeah.
And with just 3 minutes to spare.
Okay, it push. And OC1 dash T. Okay, let me get this over with right now quickly. POC is registry slash POC is image. Dash slash image. So we want run, name, and command. Okay. You know, we might actually get this into a pod today.
I mean, I would love that if we could. You have
Let's do this
120
work.
seconds. Go.
No, I didn't connect to it. Oh, I need dash TI. So stupid. POW, quickly. Yay! It doesn't crash.
I love how happy we get.
It's gonna take some time
Why does it take that long?
because they have to pull the images into the node.
Oh, yeah, that makes sense.
Yeah. So it might work, it might not. Just
I
make sure
hope
you
it
have the
does.
URL connected.
The what?
Make sure you have the curl command ready to go.
Oh, yeah, okay. Like a local host one, right?
Yes. Apparently, I'm gonna image pullback. Oh, of course, I'm gonna image pullback. Okay, my fault. Let's try this one more time. POW2. Okay, it's being created. Let's see if it works.
I hope it does.
I hope it does too. I love how we get so happy for like the smallest thing. Okay, so the image is being pulled to the system now.
That is incredibly exciting.
So for people that want to know what's going on, I cannot actually do in this terminal, but can you go to the second terminal?
Which one? No. Oh, it's up.
It's up? Okay, nice. Okay. So we are in pod. Okay, so we have 16 CPUs in this system. So
Nice.
keep that in mind. What? Master background. Okay, go. Run your command.
This is gonna be fun. It works.
Yeah, it works. So I guess the next video will actually try to get this across. This is like across multiple systems.
This is so fun. This is incredible. All right. So at least we have accomplished a good portion of our objective for today's episode. We actually got it running on an OpenShift. an OpenShift a cluster. Well, not necessarily
So
the cluster, but we got it running on a pod within the cluster, right?
yeah, so zoos have like mentioned something kubectl expose. Uh, in an OpenShift cluster, there's actually a better way of doing this, and it's called routes. We can use that for the next video when we go back to this. And this will allow us to just get a specific name and hit it directly using DNS. While when you do expose, it can do inject, it can be the IP address directly. There's a lot of other ways you can do it too. Kubernetes just does a simple, like, Kubernetes have multiple ways of exposing stuff. OpenShift have one additional one on top of what is provided. And it's very good for like HTTP layers or TLS layers, which is majority applications.
Makes sense. Right. Okay. So we have accomplished, as I mentioned, the majority of our objective for today's episode. Now all we need to do is actually truly distribute this on the cluster and make it so Kubernetes can actually, or OpenShift, whatever. I'm just going to say Kubernetes. I know that we're using OpenShift right now, but I'm just going to say Kubernetes just so we're using a single word. But yeah, we were able to deploy it. And now next time what we're going to do is actually have it truly distribute properly on our cluster. And so now today we've got all the infrastructure set up. So we have the endpoints where the worker and the master can communicate with each other, and we can communicate with the master to get work done by the workers. And now all we need to do is actually have it run workers on multiple devices, or multiple pods in this case. And with that, we conclude this episode of the live coding series. I hope you all enjoyed. Thank you for joining in once again. We do hold this series every Wednesday in the morning Eastern time, and so if you do want to see more content like this one, please do make sure to subscribe. That way you're actually notified if you click the notification bell whenever Omer and I are streaming, and you'll be able to join our next live coding episode. Next week we're going to go ahead and continue this exact topic and maybe expand upon it a bit more, do some more Kubernetes stuff, and soon there's going to be more Kubernetes content in general on the channel as well, so make sure you stay tuned for that. And with that, anything else you want to say, Omer?
No, that's everything.
Wonderful. All right, so thank you very much everyone for joining in today, and goodbye.